4-2, Part 3. Writing very large numbers in standard form. The list below shows numbers of bacteria in 4 colonies in a microbiology lab. Estimate each number in scientific notation using a single digit for the first factor. Then determine whether each statement is true or false. So let's look at colony A. 79,854,000. Colony B. 2,124,000. Colony C. 6,180,000. And colony D, 397,000. So it says estimate each number in scientific notation using a single digit for the first factor. So what I want us to do is estimate to scientific notation. So we're going to have our decimal behind the first non-zero digit for each of these. Think about it that way. So if I have 854, 7.9, if it's 5 or greater, we're going to round this 7 up to an 8. So 8 times 10 to what exponent? How many places would I need to move my decimal so that it would end up being at the back of this number? 1, 2, 3, 4, 5, 6, 7. So 8 times 10 to the 7th would be scientific notation estimated to a single digit. 2.1, that is 2 times 10 to an exponent. Moving it to the right, 1, 2, 3, 4, 5, 6. So this is 2 times 10 to the 6th. Is colony B. Colony C, 6.1, that's just 6 times. Think about moving your decimal to the very end because that's where it was in the original problem. 1, 2, 3, 4, 5, 6 times 10 to the 6th. And if we move this one to the very back, 3.9, first of all, we need to be round to 4 times, and then move it 1, 2, 3, 4, 5 decimals. So I have listed each one of these in scientific notation and using a single digit for the first number. So I will use these to help me answer the questions true or false. Colony A has 40 times as many bacteria as colony B. Well, colony A we listed as 8 times 10 to the 7th. Colony B we listed as 2 times 10 to the 6th. To answer this question, the first thing we will do is we will divide 8 divided by 2. Well, 8 divided by 2 gives me 4. Next, we will look at the powers of 10. We have 10 to the 7th. If we divide it by 10 to the 6th, remember when you are dividing like bases, don't we subtract exponents? So 7 minus 6 would give me 1. So here I have 4 times 10, which would be 40. So therefore, the statement is true because colony A has about 40 times as many bacteria as colony B. You see, I divided these two numbers and I divided these two numbers. And 8 divided by 2 was 4. 10 to the 7th divided by 10 to the 6th, subtract exponents is 1. And 4 times 10 gave me 40. So this first statement is true. Let's look at B part. Colony C has about 30 times as many bacteria as colony B. All right, colony C We listed that in scientific notation as 6 times 10 to the 6th. Colony B is 2 times 10 to the 6th. So if we were to divide 6 divided by 2 times 10 to the 6th divided by 10 to the 6th, 6 divided by 2 is 3 times 10 to the 6th divided by 10 to the 6th. If you subtract those exponents, 6 minus 6 gives you 10 to the 0. Also remember, students, if you just reduce that, a number divided by itself gives you 1, but remember, anything to the 0 power is 1, so this is 3 times 1 equals to 3. So therefore, colony C is about 3 times, has about 3 times as many bacteria as colony B. My statement said 30, so that is not true. The answer was 3. So B is false. And let's look at C. Colony B has about 5 times as many bacteria as colony D. So colony B is 2 times 10 to the 6th, and colony D, looking back where we listed out, scientific notation is 4 times 10 to the 5th. So let's compare them. If we divide 2 divided by 4 times 10 to the 6th divided by 10 to the 5th. Well, 2 divided by 4, if you punch in your calculator, that's a half, or 0.5, times 10 to the 6th divided by 10 to the 5th. When you're dividing, subtract the exponents and you get 10 to the 1st. So if you multiply 0.5 times 10 on your calculator, you get 5. So therefore, it says that colony B is 5 times, has 5 times as many bacteria as colony D. Therefore, this is a true statement.